Hello everyone, welcome. Today we are diving into one of the most important shifts in cybersecurity, which is zero trust architecture. With the explosion of cloud services, remote work, and an increasing number of cyber threats, we need to rethink how we approach security. This talk is going to explore why the old ways of securing our networks no longer work and how zero trust is reshaping the future of security. Here's a quick roadmap of what we'll be diving into today. First, I'll give you an introduction to Zero Trust and why it's essential in today's cybersecurity landscape. We'll then break down the core principles, compare traditional security models with Zero Trust, and explore the key components and strategies for implementation. After that, I'll walk you through the challenges, the future of this architecture, and wrap up with some real world case studies. Alright, let's get started. Why are we talking about zero trust today? The traditional perimeter based security models have worked for years with a simple principle: build a strong perimeter and everything inside is trusted. But here's the problem: we don't live in that world anymore. With cloud services, remote workforces, SaaS applications, and IoT devices constantly connecting and disconnecting, your network is no longer a neatly defined space. Attackers can breach that perimeter and in ways we didn't anticipate back then. They can exploit weak VPN configurations, poorly secured APIs, or even something as small as a compromised IoT device. This is where zero trust comes into play. Zero trust doesn't assume anyone or anything is safe. It shifts our narrative to never trust, always verify. Every request, whether it's internal or external, gets scrutinized. Every user, device, and even the application must authenticate before access is granted. Zero trust is not just about keeping the bad guys out, it's about constantly questioning who and what is allowed in and why. Now let's break this down. The fundamental principle of zero trust is simple: never trust, always verify. What does that mean in technical terms? It means that every single access request is evaluated on multiple factors, regardless of where the request originates. Inside or outside the traditional network perimeter, continuous authentication is crucial here. For example, even after logging in, the system continuously checks if the session is valid. Looking at the device health, location, user behavior, and other context-based parameters. We are not just stopping at username and password anymore. We are checking things like whether the device is jailbroken, whether the session request is coming from the unusual geographical location, or whether the user's behavior matches the normal patterns or not. Then we have micro-segmentation. Then this involves breaking up the network into smaller, isolated zones where traffic can be scrutinized in real time. Think of it as creative virtual firewalls between different parts of your environment. If a thread gains access to one segment, it's trapped there. If it can't move, literally, and of course least privilege access is non-negotiable. In a zero trust model, users and devices are only given the minimal permissions they need. This way, even if an attacker gains an access, their impact is limited. Traditional security versus zero trust. Out with the old, in with the new. So let's take a look at how zero trust contrasts with the traditional security models in traditional perimeter security ways. So in an old way, trust was implicit inside the network. Once someone was inside, they could move around freely. The problem here is that this model relies on a strong outer defense, but once that's breached, attackers can move literally within your network, compromising multiple systems. Think about it like this: if one system gets compromised in a traditional setup, you could lose the whole network. In zero trust, we turn that approach on its head. Instead of relying on network location as the basis for the trust, we shift focus to identity, device posture, and contextual signals. For example, when a user requests access to sensitive data, we don't just check their identity. We also look at the security posture of the device they are using. Is the device patched? Is it running an up-to-date version of the OS? What is its current security status? We even consider the user's behavior. Are they accessing data in ways they normally wouldn't? We call this risk-based access control model. And it's a game changer for detecting anomalies and threats in real time. What are the key components of ZTA implementation? Now, how do we put this into practice? Let's break down the key components of a successful zero trust implementation. First up is identity and access management. IAM isn't just about usernames and passwords anymore. We are talking about multi-factor authentication tied into a centralized identity provider that controls access to all resources. You'll also want to implement single sign-on or in SSO to streamline access management, but with continuous validation. So even if a user signs in through SSO, they are reevaluated continuously throughout their session. Next, microsegmentation. Think of this deploying virtual private zones within your network. We use tools like software-defined networking, SDN, or network access control, NAC, to isolate critical resources. For instance, instead of monolithic flat network, we are now creating microperimeters around sensitive assets, such as databases, applications, and even individual workloads. Then there's behavioral analytics. This is where machine learning and AI comes in, constantly monitoring user and device behavior. It's no longer just about someone is accessing, but how they are accessing it. AI can identify unusual behavior patterns and trigger alerts before a breach happens. Finally, we have policy enforcement points or PEPs. These are the checkpoints within the network where all traffic is validated against security policies before moving further. We enforce security policies at network layer, application layer, and even user layer using tools like next-gen firewalls, IDS, IPS, and security web gateways. So next one is the implementation strategies. Let's talk about strategy. How do we actually implement zero trust? First, you want to nail down your identity and access management. This is where MFA or multi-factor authentication becomes your best friend, because passwords alone just aren't cutting it anymore. Then move on to microsegmentation. You can use tools like VMware, NSX, CISO's application-centric infrastructure to implement software-defined microsegmentation. These tools allow you to create granular policies that govern how workloads can interact with one another. You could, for example, restrict access so that your finance department can't communicate with HR system unless it's absolutely necessary. Policy enforcement is next. Implement next-gen firewalls, secure web gateways, and intrusion detection systems at every layer of your network. These tools continuously enforce your security policies, ensuring that no unauthorized traffic makes it through. You can use orchestration platforms like Palo Alto Networks or Fortinet to streamline this process and ensure that security policies are updated automatically as the new threats emerge. So what are the challenges and considerations? Of course, implementing zero trust isn't without its challenges. One of the biggest hurdles is resistance to change. Your users and even IT staff may push back on the idea of continuous authentication because it feels cumbersome. That's where user education comes in, helping everyone understand that the extra steps are about keeping the network secure. Then there's technical complexity. Many organizations have legacy systems that weren't designed with zero trust in mind. Integrating these older systems with modern zero trust components can be difficult. For instance, if your legacy application doesn't support multi-factor authentication or microsegmentation, you may need to either update it or deploy workarounds like virtual patching or network level access controls. Latency and performance can also be a concern. Continuous verification can slow down workflows if not optimized correctly. To mitigate this, we need to ensure that our network infrastructure is built to handle the additional checks without introducing significant lag. Finally, let's talk cost. Implementing zero trust requires investment, not just in technology, but also in training, processes, and possibly even infrastructure redesign. But remember, the long-term security benefits are far outweigh the upfront costs. So, what is the future of zero trust architecture? The integration of artificial intelligence and machine learning is going to play a huge role in the evolution of zero trust. AI will help us automate threat detection, allowing the system to make real time decisions about who and what is allowed in the process. Imagine AI driven systems that can dynamically adjust security policies based on new threats as they emerge. Then there's blockchain technology. Blockchain could be used to create decentralized identity systems, making it even harder for attackers to impersonate users. By eliminating the need for central authorities in authentication, blockchain will help reduce the risk of single points of failure in identity management system. Quantum computing is another future consideration. As quantum computing becomes more powerful, our current cryptographic algorithms will become obsolete. Zero trust will need to evolve to include quantum resistant encryption methods to protect against quantum level threats. And of course, with more businesses moving to cloud and edge computing, zero trust will need to scale to provide lightweight, flexible security for these distributed infrastructures. So, next, the case studies and industry trends. Let's look at how zero trust is being used successfully today. For example, in the US government, several agencies have adopted zero trust as part of their cybersecurity strategy. By continuously monitoring insider activity, they have been able to drastically reduce the risk of insider threats. On the enterprise side, companies in the finance and healthcare sectors have reported a significant drop in breach incidents since adopting zero trust principles. Regulatory pressures like GDPR and HIPAA are also pushing more organizations towards zero trust models. The numbers are clear. Zero trust is more than a trend, it's becoming an industry standard. So, here's the bottom line. Zero trust architecture is the future of cybersecurity. We can't rely on traditional perimeter defenses anymore. They just don't cut it in today's threat landscape. ZTE, with its continuous authentication, microsegmentation, and least privilege access, is way forward. Yes, implementing it can be challenging, but the benefits far outweigh the hurdles. By embracing zero trust, you're not just protecting your organization from today's threats, you're future proofing it for whatever comes next. It's time to take the leap and make zero trust part of your security strategy. So, yeah, thank you so much for your time. Zero trust is the future, and we are all in this together and make your organization stronger, smarter, and more secure. Let's go out and build the future of cybersecurity today. Thank you.